Hi friends, in this video we are going to discuss about alternator. What is the definition and basic principle? Alternator, definition and basic principle. Let's see, first of all, what is the definition of alternator? Alternator nothing but a rotating AC generator, which converts mechanical energy into electrical energy by utilizing DC excitation. What is that? DC excitation. So, alternator nothing but a rotating AC generator which converts mechanical energy into electrical energy by utilizing the DC excitation. This is the definition for alternator. Now, what is the basic principle of my alternator? In generally, the basic principle is same for generators. What is that basic principle? The basic principle is that whenever a rotating conductor placed in a magnetic field, it produces EMF. What I am telling that? Take a stationary magnetic field, for example, North Pole and South Pole. This is my stationary magnetic field with some flux density B. And whenever a rotating conductor, this is my conductor, which is rotating with v velocity. This conductor rotating with v velocity, that's why it is called a rotating conductor. Placed in a magnetic field, this is my magnetic field. Then it produces EMF. That EMF is equals to BLV sine theta according to Faraday's law. According to Faraday's law, EDY is equals to BLV sine theta, where B is the flux density, where L is the active length of my conductor, where V is the velocity of my conductor. But what is the theta? Can you give me the answer? Yeah, very good answer. Here, theta is the angle between flux density and the velocity. Very good answer. Okay, so this is the magnitude of induced EMF. How much EMF produces in our alternator? If they ask you a question, EDY is equals to BLV sine theta, where theta is the angle between flux density and velocity. Are you okay? Now, what is the direction of our alternator induced EMF? What I am asking? Can you tell me the direction of induced EMF? Then they will give you the direction by dash law. Can you tell me which law is using where to determine the direction of induced EMF? Very good answer. According to Fleming's right hand rule, we can give you the Direction of induced EMF. What is that? According to this Fleming's right hand rule, take the right hand 3 fingers 90 degrees to each other. Right hand 3 fingers 90 degrees to each other. Right hand 3 fingers. In that, one is the thumb, other one is the forefinger, and next one is the middle finger, where the thumb indicates the motion of the conductor, which is nothing but mechanical action. Motion is nothing but mechanical force. And forefinger indicates the flux direction. Flux nothing but this is a magnetic force. When this rotating conductor placed in a magnetic field, then it produces EMF, which is nothing but electrical quantity. This is given by Fleming's right hand rule. According to Fleming's right hand rule, when we are stretching the 3 fingers of right hand 90 degrees to each other, thumb indicates the motion of the conductor. Forefinger indicates the flux direction. When these two are exist here, then EMF induces. When we are giving mechanical energy to the alternator, it gives you electrical energy. That's why it is called generator, which converts mechanical energy into electrical energy by utilizing the DC excitation. The DC excitation, nothing but magnetic field. We are giving the magnetic field by the field winding, by the DC supply. So the thumb indicates motion of the conductor, forefinger indicates flux direction, and middle finger indicates EMF direction. So this is a basic principle of my alternator. One is the basic principle and its magnitude of induced EMF, and next to direction of induced EMF. Okay. So we discussed about dynamically induced EMF or induced EMF. Now I will ask you a question. Can you tell me what is the difference between induced EMF and back EMF? Anyone? Give me the answer. Induced EMF and back EMF. Whatever it may be, dynamically or statically, whatever. Induced EMF and back EMF. Or it is called generated EMF. It is also called generated EMF. This is my generated EMF. Eg is equals to BLV sine theta. This is my generated EMF. Can you tell me where is my back EMF? Here, some controversy. What is the difference between generated EMF and back EMF? Let's see here. We have a generator and motor. In generator, the mechanical energy converted into electrical energy. In motor, electrical energy converted into mechanical energy. Nothing but the resultant quantity of generator is EMF. The resultant quantity of motor is torque or speed. EMF or current, torque or speed. This is very clear, right? The generator produces EMF, that's why it is called generated EMF. Of course, the motor produces the torque or speed. But I am asking you, what about back EMF? Can you tell me? Yeah, very good idea. Sir, back EMF belongs to motor. You are saying that, like, yes or no? In general, once think, the motor should develop EMF or torque. Yeah, motor should develop the torque. Then why the back EMF is there? Why that concept is there in our motor? Actually, Actually, the EMF concept belongs to generator only. But you are telling that back EMF also is there. That concept belongs to motor. Is it correct or not? Sir, this is 100% correct. Very good. If the EMF is back EMF, if this back EMF concept belongs to motor, when this is 100% correct answer, then what is the concept belongs to generator? Likewise. What is that concept? Actually, the concept of the generator is generated EMF. The concept of the motor is torque. But now you are telling that back EMF concept also is there. This is belongs to motor. This is the primary concept and this is the secondary concept. And for generator, EMF is the primary concept. Then what is the secondary concept? Here the secondary concept. Here the primary concept is the torque. Secondary concept is the EMF. Here the primary concept is the EMF. Secondary concept is the torque. That is called back torque. That is called magnetic drag. Magnetic drag. Reverse EMF, reverse torque or magnetic drag. This is very important. This is very important. Now I will explain you about this magnetic drag. In every motor, generator action will take place. In every motor, generator action will take place, which produces the EMF. What I am telling you, I have a motor, but in this motor, the generator action is taking place. Then some EMF produces. That EMF is in opposite direction to the supply voltage. The generated EMF in the motor is opposite direction to the supply voltage. Hence, that EMF is called back EMF or counter EMF. This is 100% correct. Likewise, in every generator, motor action will take place, which produces the electromagnetic torque, which is in opposite direction to the prime mover torque, which is in opposite direction to the prime mover torque. Hence, this torque is called counter torque. This is a counter EMF, this is a counter torque, this is a back EMF, this is a magnetic drag. Magnetic drag. So here the statement is that, in every generator, motor action will take place. Motor action will take place, which produces electromagnetic torque, which is in opposite direction to prime mover torque. Hence, this torque is called counter torque or magnetic drag. What is the statement? Once read carefully. In every generator, motor action will take place, which produces electromagnetic torque, which is in opposite direction to the prime mover torque. Hence, this torque is called counter torque or magnetic drag. This is the concept of alternator. Very easy. Yes or no? Yeah. You are thinking this is very easy topic, sir. You are getting or you are giving the concept which is well-known concept, sir. Don't waste time here. Yeah. I will ask you a simple question. Give me the answer. Right. See here. Flux density 1 Weber per meter square. My active length of the conductor 1 meter. Actual length of the conductor 1 meter. and my generator is rotating at 1000 rpm. Generator is rotating at 1000 rpm. Radius of my rotor is 1 meter. Radius of my motor is, or my rotor is 1 meter. And the angle between flux density and velocity 90 degrees. Angle between flux density and velocity 90 degrees. Then give me the dynamically induced EMF developed in the alternator. This is the question. Give me the answer fast. Hold the video and calculate the question and give me the answer. Yeah, give me fast. So this is very simple question. We have a formula E dy is equals to BLV sine theta. And you said that the flux density 1 Weber per meter square. Very good answer. And length of the conductor 1 meter. Yeah, good answer. And velocity, just leave them. And sine theta, theta is 90 degrees, sine 90 is the 1. What is velocity? Give me. If you take 1000 here, then what is the answer? 1000 volts. If you give this answer, you will get a Nobel Prize. Okay. If you want Nobel Prize, then take 1000 here. Is it correct? What I given you? I given you the speed of my rotor 1000 rpm. But here they want the velocity. Velocity nothing but meters per second. The speed, velocity, meters per second. But I given you here number of revolutions per minute. I given you number of revolutions per minute, but here you want that meters per second. Then you get wrong answer. Now tell me which is correct answer. We have to calculate velocity. Can you tell me what is velocity formula according to physics? According to 10th class SSC. Velocity is nothing but displacement by time, rate of displacement. Yes or no? What is the displacement for one revolution? Here my rotor is rotating one revolution. What is the displacement for this one revolution? For this one revolution, the circumference is the displacement. The displacement for one revolution is 2 pi r. What is time taken to complete one revolution? I have to calculate the time. What is the time? The time which completed one revolution. Actually, I given n revolutions per minute. What is the meaning of this? Number of revolutions per 1 minute. 1 minute bole to 60 seconds. N revolutions for 60 seconds. Then what is the time to complete one revolution? How we can calculate? Yeah, cross multiplication. 1 multiply 60 by n. So the time to complete one revolution is 60 upon n. Now tell me what is answer. 2 are nothing but 2 times of the radius is the diameter. So d pi n upon 60, or simply velocity is equals to pi d n upon 60 meters per second. So they will give you data in terms of RPM. We have to calculate velocity in terms of meters per second. So here flux density 1, length of the conductor 1, sine theta 1. But velocity d pi n, or pi d n upon 60, nothing but pi and diameter. Radius is 1 meter. Diameter is nothing but 2 meters and the speed is 1000 rpm upon 60. Now calculate and give the answer. This is 100% correct answer. So don't be hurry. Listen or read the question carefully. Analyze the formula carefully. Substitute the values carefully. Calculate carefully. Then give the answer. Whatever you got the answer, that may be there in your 4 options. But that may not be correct answer. Okay, so be careful. This is very important question. They may ask you in our exam. So here you have to remember the formula. Velocity V is equals to pi dn upon 60 meters per second. This is clear, right? So what is the overview of this video? What is the overview of this concept? Tell me. First, what I told you, the definition of alternator. Alternator nothing but a rotating AC machine which converts mechanical energy into electrical energy. How is that? Here we are giving mechanical energy, but this alternator gives us the electrical energy, nothing but which converts mechanical energy into electrical energy, nothing but which converts the speed or torque into voltage or current. Speed or torque into voltage or current by utilizing the excitation. Which excitation? DC excitation. This is my alternator. Here, armature winding carries the AC supply and field winding carries the DC supply. That's why it is called double excited machine, I told you. This is a double excited machine. And generally, the stationary armature is more advantageous than rotating armature. The rotating armature is not preferable. Stationary armature is more preferable for easy connection of current, for good insulation, for less cost, less maintenance, for good voltage regulation. Like that, many advantages are there for stationary armature. Of course, we discussed about this. Then after what I told you, the basic principle of alternator. Whenever a rotating conductor placed in a magnetic field, then it produces EMF. That EMF, E dy is equals to BLV sine theta. Who said you this equation? This equation given by Faraday's law. Here, where theta is the angle between flux density and velocity, you should remember this. And here we derived a formula, velocity V is equals to pi dn upon 60 meters per second. Very important thing. The direction of induced EMF given by Fleming's right hand rule. Fleming's right hand rule. According to this rule, stretch the 3 fingers of right hand 90 degrees to each other. Thumb indicates motion of the conductor, which is nothing but mechanical quantity. Forefinger indicates the flux direction, which is nothing but magnetic quantity. When these two are there, then it produces the EMF, which is nothing but electrical quantity. This is an overview. In every generator, motor action will take place, which produces the torque which is in opposite direction to the prime mover torque. That's why the torque is called counter torque or magnetic drag. This is simply about the overview of alternator up to now. Thank you.